my CFCamp presentation on the 25 most dangerous software weaknesses. Now, obviously, I'm not here in person. I apologize for that. I do have my kids' graduation events going on here, so I just wasn't able to make it to the conference this year, but hope to be there in the future. So without further ado, let's get started on the presentation. And so yeah, today we're talking about weaknesses in your software that are causing security vulnerabilities. But a little bit about me first here. I've been working with Cold Fusion for about 20 years or so, as well as with Lucy since its early days as well. Back to Rilo. My company, Foundeo, is the CFCamp sponsor, and we have several products that you may have heard of, including FuseGuard, which is a web application firewall for Cold Fusion. HackMyCF is a Cold Fusion server security scanner, and Fixinator, the latest product, is a code scanner that you can scan your source code, your CFML source code, looking for security vulnerabilities. And that works either locally on your computer, or you can run it in CI environments and have it automatically scanning your code continuously. I also do a lot of consulting work, which includes things like code reviews, server reviews, CFML security training classes. And you also might know me from the lockdown guides, in the Adobe Cold Fusion lockdown guides, going all the way back from CF9 up until Cold Fusion 2023. I'm the guy that makes cfdocs.org, CFScriptMe, and my latest little CF side project is cfbreak.com, which is a newsletter for Cold Fusion and Lucy developers. Enough about me. Let's get to it. So where did this list of 25 most dangerous software weaknesses come from? Well, it actually comes from a company called MITRE, which is kind of funded by the US government, and they're the ones responsible for the CVE. And so this list is actually called the CWE, which stands for Common Weakness Enumeration. And so it's kind of a way of picking out or classifying a software weakness type. So this is what the CWE top 25 list looks like. And so each weakness has a number, but we'll get into the details of what the actual weaknesses are. And the way that they create this list is they look and see how many vulnerabilities, so CVEs, have had this type of weakness, and then they look at what was the severity of that vulnerability, and then they come up with this score. So the ones at the top were ones that occurred a lot, but were also in high severity, so making them the most dangerous. But the thing about any sort of top 10 list or top whatever list is that there's often more than the end of the list. You can keep going. So as you can imagine, there's a lot more than 25 software weakness types. And you could, if you're looking at this list here, you can see going all the way up to like 863. So there's hundreds of different types of weaknesses to be aware of, but we're going to talk about the ones that are occurring the most commonly today. The other thing to keep in mind is that these things change over time as well. So certain types of vulnerabilities become more popular, more exploitable, and then maybe we as developers get better at preventing them, and then another type of one rises up to the top. So these things kind of go back and forth a bit. So starting with the list, we're going to work our way backwards from 25 all the way down to the most common ones. Is improper control of generation of code. So this is a code injection vulnerability, and a few different ways that this can happen in your CFML code might be through like the evaluate function, for example, or the IIF, or the inline if function, or even the CF include function. So let's take a look at an example of what it might look like in the inline if function here. And before we get into that, we're going to actually look at a real world example. So here's a bit of code here in this application I have. So if we go to a news story and then we cause an error, it's going to run this error.cfm, which is this generic error handler. And part of this error handler, the developer thought it would be useful to enumerate over the URL scope and output all of the values in the URL scope. But they use the evaluate function here to do that, which is going to be cause for concern here, because whenever we use the evaluate function, anything going into it needs to be a trusted value. If it's not a trusted value, then it can be exploited and code can be executed. So let's take a look at how that might work here in the error handler. What we're going to do here is I'll copy this here and show you a little bit better what we're doing here so you can see it. We're passing in ID equals X, and that's just going to cause this error handler to happen. And then we're also passing in ID.listAppend, and then we're passing in the now function to that list append. So what's going to happen as it's going through the loop, it's looping over each key in the structure. So the first one is going to be ID. That's going to output ID, URL.id, and it's going to evaluate URL.id. The second time through the loop, it's going to think that this is the key. And you'll see that for the key, and it'll evaluate URL.id.listAppend now. So when it actually gets executed, it will list append the value of the now function. You can see if we reload this, that the time will be changing. So it's a bad idea, obviously. You want to avoid this. You don't want to allow somebody to just be able to put CFML code in the URL and have it execute. So how do we fix something like this? And for evaluate, in most cases, you can fix it with bracket notation. So instead of doing this evaluate here, I'm going to comment that out so you can still see it, but I'm going to fix it here using URL bracket key. And that, using the square bracket notation, does not cause the remote code execution. So now we can see this just evaluates to 1 and this evaluates to X, as the developer was expecting. So that's kind of showing the dangers of this type of vulnerability in your code. So you really want to avoid evaluate within your code and go through. It's easy to find. Just do a search in your code for evaluate. You can look at all the cases of it. Now, not every case of evaluate in your code might be vulnerable like this one is to exploitation, but you do want to make sure that none of the inputs going into the evaluate function are coming from an untrusted source. And what would an untrusted source be? Basically, anything that's not hard-coded within your code. So anything from the URL scope, form scope, CGI scope, headers, request body, something coming in from another API or service, data from your database, anything like that could potentially be untrusted. So I mentioned also the inline if function is another way that this might happen. So if you look at this function, the first argument here is a condition. The second and third arguments are either the value if it's true or the value if it's false. And we can see an example of this here as well in the application. So what we're doing here is, let me all right, we're going to go to this bank admin page and I'll just delete through a few of these. Oh, let me rebuild the database actually. All right. So right now we don't have any messages in here. But if I put in something here as a name, Mr. Now, and go back to this page, you can see here, again, it's evaluating this as a expression, um, as a CFML expression. So it's allowing the code to execute that was passed in. So again, with the IIF function, inline if, you don't want to allow any sort of untrusted inputs into that function at all. And again, search your code for this. You should be able to find those and replace those with something else. So the solution a lot of times for the inline if function is to use the ternary operator, which would be essentially you parentheses, a question mark, the value of true, colon, the value of false. And that, when you rewrite it, will not actually evaluate expressions dynamically like the inline if function does. So we already kind of covered this, but for evaluate, use the URL brackets or use the square bracket notation instead. That will even work on like if you're doing dynamic query names and things like that, column names within a query, you can do 2 sets of square brackets. All right, so the good news, these are easy to find. They're also fairly easy to fix. So you can kind of like, in maybe a couple hours, depending on how many you have, be totally, solved with this vulnerability in your code. And it's easy to know you don't have the issue here because you've rooted out those functions that are potentially dangerous and rewritten the code. The bad news, these are very dangerous if you do actually have them. And if your code is really, really old, like going back to the early 2000s, you might have a lot of these. And the reason for that is that back in like Cold Fusion 4.0, I don't think it was until Cold Fusion 4.5 where the scopes, like the URL scope or the form scope, were actually structures that you could manipulate as a structure. So until then, it was very common to use evaluate to be able to dynamically access the name of a form field or a URL field. So you might have quite a bit of code like that's using that sort of thing if you have a lot of old code. All right, down to number 24, improper restriction of XML external entity references. These are also called XXE for short. So what is an XML entity? Similar to an HTML entity, where you have a less than symbol that you want to encode in an HTML page, you have to encode it as ampersand LT semicolon. So similar to HTML and XML, you would do it the same way. But what XML does is it allows you to define your own entities. And this is kind of like a really strange feature. But the authors of XML way back in whatever was invented, late 90s or early 2000s, decided that this would be a useful feature. And it turns out it was very useful for attackers to use this feature, and it's constantly being used as something attackers use more probably by attackers than actual legitimate uses. But in this case, we're defining an entity called XXE that will make an HTTP request to that URL, http bin.org/uuid. And whenever we are outputting ampersand XXE semicolon, it's going to put the value of whatever was fetched from this URL. In this case, it's going to be a UUID. So yeah, I've got an example where we can see this. So here's essentially the same code we just saw on that slide, and I'm going to bring it up here. Running a little slow for some reason. Could be that this service is down. All right, well, you'll have to just take my word for it and assume what we would do here was output a UUID here in this result, and you would see that. So in order to fix this, in Adobe Cold Fusion, there's a third argument you can use here to the XML parse function where you can pass in allow external entities equals false, and that will disable it in the XML parse function. On Lucy, in your application CFC, you can use this .xml settings and pass secure equals true. And there's a ticket here with more info on that. But some other ways you can handle this is to simply avoid parsing XML from untrusted sources. So maybe if you have some code that allows somebody to post to your site using XML, like an API or something, but it supports XML and JSON, but everybody's using JSON, maybe it's a good idea to just disable the XML input if possible. You can also check the inputs before you run XML parse for things like doc type and element to see if it's using those dangerous features. I've written a safe XML parse function, which kind of is just an XML parser written in CFML, where it doesn't do any of those dangerous features. It just doesn't simply implement them, and it tries to return a struct similar to what XML parse does. There's also another thing here where this link here where you can it will convert XML into JSON for you, which is pretty handy. Number 23, uncontrolled resource consumption. So essentially what we have here is a denial of service attack. And this is where the attacker has found a way to cause your application to do a lot of work. And if the attacker can make requests to your applications with minimal work and cause your application to do more work, eventually what's going to happen is your server is going to become unresponsive. So some things to think about, make sure that you are limiting your database queries if you have very large database tables with like millions of records. Make sure you're using like limit or top on those queries to limit them. When you're doing looping, make sure that there's a maximum iteration when you're going over a loop. Hash DOS is another type of vulnerability related to this that we've seen in Cold Fusion or Lucy applications. And this is where like the post parameter limit in Adobe Cold Fusion would come into play here, and make sure that that has been set to something not excessively high. Okay, number 22, race conditions. And this is essentially for CFML applications, this is where you just need to be aware of synchronization issues. So most of your code generally is going to be like single threaded, but if you have things in application scope, you have to be aware that it can be accessed by multiple threads. So things like application scope, server scope, or session scope in some cases could potentially need to be aware of that. Your multi-threaded code, if you happen to be using like CF thread or array each with the parallel argument set to true. Using database transactions here can also help to ensure that consistency. And if you are using array each, make sure that you're using the local scope or the var scope within your function that gets called for each element of the array, because I've seen that cause issues as well, where if you're not using the var scope, and then it gets confused about pretty quickly. All right, number 21, server-side request forgeries or SSRFs. So this happens when your server makes an HTTP request to some sort of arbitrary URL. A URL may be controlled by the attacker that they're then able to gather information from, or maybe they are trying to use it to bypass your firewall to be able to connect to, maybe you have some sort of database with a REST API on it, or some sort of cache with a API, and then they're able to fetch information out of that or insert information into it potentially. Another place where this has been pretty prevalent are the cloud metadata APIs. So if you're not familiar with that, like if any cloud provider like AWS, Azure, Google Cloud, even like DigitalOcean, Linode, have these cloud metadata IP addresses where if you make a HTTP request to this IP from your server, they have a little API set up on that IP address that will return instance metadata about your, like if it's an EC2 instance, it will include all sorts of metadata. So on AWS, there's instance metadata service version 1, which is vulnerable to this type of attack, and then they've made a version 2, which you can enable and disable the version 1, which would not be vulnerable to an SSRF attack. So pretty much anywhere you can have a URL could potentially be vulnerable to a SSRF attack. So things like CFHTTP are kind of the obvious one, but also things like CF document, CF HTML to PDF, those types of things can also cause this. Maybe less obvious, think something like is image file, XML parse, as we already saw, was making an HTTP request to an external service. And then Brian Riley's got has done a lot of research on this and has come up with a list of tags and functions that might cause SSRF issues, which you could take a look at. And so real quick, let's look at our code here. In this, by the way, this bank of security application I should have mentioned is my application that is full of security holes that I use for security training and a lot of my presentations. So you're going to see all the code here, and this application is really bad usually and easy to exploit. So here's an example of a bank statement PDF, and you can see here the year is just from the URL. So now it says June whatever. And so I can do something like image source foundeo.com images foundeo.png. And you can see here that by putting an image tag here and for the year, it actually caused that to show up in the PDF. And so now the PDF gets rendered on Cold Fusion or Lucy side of things with the CF document tag. So that HTTP request to fetch this image actually happened on the Cold Fusion or CFML server itself. So that is a SSRF attack because that's happening. The request is originating from inside, your network firewall inside your application server's network, which might have access to other resources that it needs on the network. Okay, down to number 20, incorrect default permissions. So one of the most common things I see here would be when you're setting up your CFML server, you're giving the user that the CF engine is running as full permission to the entire web root. Now, it doesn't need full permission to the web root. It just needs read-only permission to any CFM or CFC file in order to be able to execute it. It only needs write permission if you're doing something like a CF file or a file write and trying to write a file somewhere. Those are the only places where it's going to need write permission. And then, of course, it's also going to need some write permission in the actual installation directory as well to be able to write log files and things like that. So take a look at the lockdown guides and make sure that you're avoiding the defaults on as much as you can here. Number 19, improper restriction of operations within the bounds of a memory buffer. So this is this is one of those vulnerabilities where we can say thanks Java, because Java is memory safe, and it handles these types of coding errors for us, so we don't have to worry about them. So and if you're programming a language like C or something like that, where it's not memory safe, and you can actually go outside of the the chunk of memory that you're supposed to be running your program in, that's where different types of buffer overload, overrun type of vulnerabilities happen. So Java doesn't let us do that. Um, and if there is any sort of memory safety issues, that would be a vulnerability in Java itself that they would have to patch in the a Java update. So it's not something you need to worry about as a CFML developer. So there's going to be a couple of these throughout the list of 25 here that we're just going to say, thanks, Java, we don't have to worry about that one. All right, number 18, missing authentication for a critical function. So authentication is the user is who they attest to be. And then authorization is that the user has permission to perform a certain action. So this is something we see a lot sometimes, is that the developer just forgot to put any sort of authentication on some sort of resource. So this happens quite a bit with like S3 buckets that are just wide open, or even certain APIs that just don't have any sort of username or password protection on them. And so a recent example of that, it's going back a few months ago, is the Optus data breach, which was in Australia. And I think this is like a mobile phone provider in Australia that basically, I think almost the entire population of Australia was included in this breach. All their information was available to this API without any sort of authentication. So, and this is a little bit tricky too, because as a developer, we're writing code, we're testing to see if it works, but we also need to test to make sure it doesn't work in certain cases. Like if the user is not logged in, does this page still work or not? And that's something we don't always think to test. So it is easy to overlook as a developer, these types of things. And so that's why it's, on this list. Okay, command injection. So this is where you have you're executing some sort of operating system command, and there is the ability for somebody to inject something else into the command execution. So maybe an example of that would be something like the CFExecute tag we have here. Missing authorization. So this is where the user's logged in, but we forgot to check and see, like, does this user have permission to view this particular resource or not? So a good example of this is called an IDOR, or an insecure direct object reference. And so this is where you have like document.cfm $ID equals 123. And that one, maybe you have a link to and you click on it, and then you go up into the address bar and you change it to 1234, and then you're getting somebody else's document. So that's just a very basic example of this, but it does happen all the time, and it is something you do need to double check in your code as well to make sure that it's not allowing full access to any document. It's only allowing access to the documents or resources that the user should have access to. Again, you can do testing here to check for this as well. Use of hard-coded credentials. So having passwords and API keys within your code. This generally, it's a good idea to take those out of your code altogether, because they can be accidentally leaked potentially in your code if your code is not, the code might live on like, a dozen developers' laptops, and if one of those laptops is stolen or something like that, then the credentials or passwords that your application uses would be included in that. So it's better to separate those out so that they're not part of your actual code and they're not included in your source code repository. And they're maybe using like an environment variable, or maybe you're going to use like a secure key storage service. A self-hosted option might be something like HashiCorp Vault. If you're on AWS, there's the EC2 Parameter Store, KMS Secrets Manager. Azure has Key Vault. GCP has Key Vault and Secret Manager. So there's all sorts of ways you could solve that. Improper authentication. So some ways authentication can go wrong is allowing weak passwords, being vulnerable to credential stuffing attacks. So this is where attackers might have a list of valid emails and passwords, and they're just going to try like millions of them on your server. So you need to make sure you have some sort of prevention in place that doesn't allow such like a brute force attack. And you can do that by having like an audit log and monitoring that and having controls in your application based on how many failed requests are coming in. Session cookie configuration weaknesses, putting the session variables in the URL, etc. One good solution to this is to use a single sign-on provider. So you can integrate with SAML, for example, in ColdFusion 2021 has some built-in functionality for that, which makes it fairly easy. I've also done similar implementations using the Java SAML library on Lucy. Works just as well. I think it's actually even the same library that Adobe is using, and that works well as well. So there's different ways of doing single sign-on, but it's definitely something to look into, since a lot of organizations have the ability to support this nowadays. So it's something you want to maybe see if your app should take advantage of. Integer overflows or wraparounds. So this is something we don't probably think about a whole lot, but so the maximum value of an unsigned 32-bit integer is around like 4,294,000,000. That number there that I have on the slide. And so what happens if you add 1 to it? What does your application do? How does it handle that? So for example, in older versions of MySQL 5, it would loop around silently to 0. So if you pass in the number 4,294,967,296, MySQL would say, oh, you mean 0? So that can cause some logic issues potentially in your application in those cases. So that's something just to be aware of. Deserialization of untrusted data. So this Java has had a lot of these types of vulnerabilities. In ColdFusion, it would pertain to if you're using the deserialize or the serialize function, or essentially the deserialize function, taking in a Java object that's been serialized. So you just want to make sure you're not deserializing untrusted data. And so I'm not talking specifically here about JSON deserialization, but on that note, it's a good idea to validate the JSON. You can use something like JSON schema for that. Null pointer dereferencing. Again, thanks Java for that. We don't need to worry about that one. Unrestricted upload of file with dangerous type. So this is something we do see a lot in CFML applications. So make sure you review your file upload code. Make sure that's always checking the file extension against a list of allowed file extensions. You don't really want to do it the other way around, where you say like, I'm going to create a list of file extensions I don't want uploaded. So CFM, CFC, JSP. Well, did you know that maybe CFML was executable on your server? Or maybe JWS was executable as a Java Web Service file on Adobe ColdFusion. So, or maybe somebody installed PHP on the server and now PHP is executable, or somebody enabled ASP.NET and you have ASPX and then a whole about 50 or so more file extensions to worry about. So the better approach is to say, okay, I'm only going to allow JPEG, PNG, GIF, PDF, and have a list like that. So also don't upload directly under the web root. So that means the destination of your CF file, action equals upload, should be like something like get temp directory. Then you check the file, make sure it's all good, and then maybe you can copy it to the web root, but don't do that until you've done all your checks. Also, don't rely on any sort of MIME type checks. So that would be like in the accept attribute, if you have image/JPEG, that can be gotten around. So don't trust those, they don't work. There is a setting, this.blocked.ext for file upload, that you can set in your application CFC. And that kind of works the way I was saying, don't do it that way, but this is just like, I would treat that as like a secondary check that you can have as well. All right, cross-site request forgeries. So this is caused by somebody causing a authenticated user to make some sort of unwanted request on their behalf. So, and it's usually triggered by a different website. So the best example I've seen of this is with Netflix, and this is going back to the days when Netflix rented DVDs. And I'm not sure if that made it to Europe or not, their service like that, but essentially the way it worked was you had a queue and you would go to their website and say, okay, I want to watch this movie, I want to watch this movie, and you'd have a list of movies that you wanted to watch in your queue, and they would mail you one. When you're done watching it, you'd mail it back to them, and then they would mail you the next one in your queue through the post mail. And to add a movie to the queue, it would look something like this URL here, netflix.com/add to queue, and then question mark movie ID equals whatever the movie ID. So the problem is what somebody figured out was if you put an image tag here on your page with this movie ID, anybody who was logged into Netflix and viewed your page would have this HTTP request made, and the cookies of the user is sent with this image request as well, so that it would think that the user was authenticated and actually wanted to add this movie to the queue. And then millions of people added SpongeBob SquarePants the movie to their queue due to this issue. So fixing it, one of the best solutions for this is actually same-site cookies. So you can set same-site to lax or strict, and it will prevent this image tag from sending the cookie, which is a great solution. But you can also do is check HTTP methods. So maybe you want to require a post for certain types of operations in your application, and don't allow them to work over GET. CAPTCHAs could be a solution, but those have their own usability issues and can be defeated with AI these days. CSRF tokens is also a good solution. There's CFML functions, CFRF generate token, and CSRF verify token that you can use here. Okay, improper limitation of a path name to a restricted directory. So this is known as a path traversal, and essentially in CFML, anywhere you have a file path and you have a variable in it, you need to make sure that that variable is not is a trusted variable, and ideally not anywhere from the user input, like in this example here where it's coming from the URL scope. So what the attacker can do in this case is, I'm just going to load this one up. So here's an about page, similar to what we just saw in that example. And they can pass in through the URL // all the way up as far as they want, and be able to read any file on the server that your CFML user has permission to read. What's worse is these with a CF include can also cause a remote code execution issue as well. So that's that's something else to makes these even worse potentially. Number 7, use after free vulnerabilities. Again, these are memory issues that Java takes care of for us. So thank you. OS command injection is very similar to one that we already looked at. So we're not going to go into too much detail on that one. But again, just make sure we're using like CF execute or things like that, that you are not allowing any sort of untrusted input into the command or arguments. Number 5, an out-of-bounds read. Again, thank you, Java. Improper input validation. So I've always thought that validation can be one of the best ways to prevent a whole number of security issues. So if you just simply validate that an integer, something that you expect to be an integer, is an integer, you could prevent a whole lot of vulnerabilities in your application just by doing that. So many times that's simply all it is. It's like there's something that's supposed to be an integer, but it gets changed into some malicious payload that then does something malicious. So if you simply validate that it's only an integer or only a certain expected value type or has a maximum length of maybe 5 characters or in certain cases, that could prevent it from being exploitable in other cases. So if you didn't pick up anything else today, one thing you could pick up is add some validation to your code. It will improve your security. Okay, so number 3 is SQL injection. So hopefully this is one you're aware of already, but essentially the classic example here is a CF query where we have a URL variable right directly in the query. And the solution, of course, to that is to use CF query param. So I'll show you here. In this application, we also have a SQL injection. And here it is doing a union and going through all the users in the table. And so this is what the code looks like here. And so SQL injection can kind of be a pain to fix. And so that was one of the reasons where I think having tools to find and even potentially fix, although it's useful just to be able to find vulnerabilities in your applications, can be handy. So one of the tools my company has, Fixinator. Here I'm just running it from the terminal locally. Here it finds, I'm just running it on the story.cfm that we see above. And so it's finding this SQL injection, and then it's asking me, do you want to fix it? And I can say, sure. And you can see here, after I do this, that it's going to go ahead and fixed it for us right there. So that can be handy if you've got a lot of these issues. You can just, especially if you have version control, you can go through and then take a look at all the diffs of everything that it's fixed for you. And it can find all sorts of issues besides just SQL injection as well. If you're using query execute, you can still have SQL injection. Make sure you parameterize those as well. In that case, you just do colon, some sort of variable name, and then you pass in a structure into the second argument. So another place or a couple things to think about is that the certain parts of the query might be you might not be able to use CF query param, so that might be like an order by clause, maybe in the limit or offset, and this varies depending on the database engine. So in those cases, you do have to be very careful that your code is written properly if you do need to use some sort of variable there. And validation. So for example, if you're doing select top something, you can use validation to ensure that that number is an integer. but use CF query param wherever you can. Yeah, so we already talked about Pixinator. This is just showing the GUI version of it. We looked at the command line version. Number 2, cross-site scripting. So again, I'm not going to get into too much detail here because I do want to leave time for questions at the end here. But essentially, this is whenever you're outputting a variable onto the page and it's being it's not being encoded as with HTML entities, for example. So you don't want it to allow somebody to be able to include like a JavaScript or any sort of client-side executable code, because then they can start doing things to manipulate the user of the application and potentially even take out data and post it elsewhere. So what you want to do in that case is replace with encode for HTML, or if you have a lot of variables within a CF output tag, you can use the encode for attribute and set it to HTML. And those two statements are equivalent there. Now, the thing to be aware of is it depends where you're outputting the variable, what the context of it is. So if it's in the HTML or like essentially inner HTML, so like inside of a tag body, then you want to use encode for HTML. If it's inside of an attribute, then you want to use encode for HTML attribute. If it's inside a script tag or any sort of JavaScript event handler attributes, like an on-click or on-mouse over, then you want to use encode for JavaScript. If it's in a style attribute or a style tag, then you use encode for CSS. Of course, the URL variable would be encode for URL. And that brings us down to the most dangerous one, which is an out-of-bounds write, and that one gets taken care of for us by Java. So a little bit learning more. I've started putting together a Cold Fusion security guide, which is just kind of some pages on some of these topics here. Feel free to ask me, shoot me an email. There will be some time, I think, at the end here for Q&A. OWASP is a good resource site. The CWE site is also good.